In the mid-1960s, the American car business faced a new kind of threat. Small imported cars kept gaining buyers, and they did it by being simple, cheap, and easy to own. The big US automakers had dominated with size and power, but that old formula started to look expensive. So the mission changed. Build compact cars fast, build them light, and above all, build them at a price that matched the imports. That shift put Detroit on a clock. Compact cars demanded different choices: thinner materials, tighter packaging, and fewer parts that looked optional. Every pound mattered because weight affected cost and fuel use. Every dollar mattered because buyers compared stickers across brands. And every month mattered because a late launch meant losing the market before the first car even arrived. Development schedules tightened, and the margin for second thoughts shrank. Inside the companies, that pressure turned into a new rule of the road. Decisions that once waited for extra testing or redesign now faced a harder question. Did the change slow production? In a race against imports, speed to market started to beat caution, one deadline at a time. The compact car boom looked like a smart response, but it also created an environment where problems could be discovered early and still be pushed aside later. Ford launched the Pinto as a top priority program, and the schedule stayed brutally short from day one. The goal stayed simple: a small car that reached buyers fast, not one that lingered in development. A hard cost ceiling locked in alongside that deadline, shaping every decision that followed. Engineers worked with a fixed target price, a fixed launch date, and very little room to pause and rethink. That pressure changed how the car got built. The usual rhythm of design, test, redesign, test again, got squeezed down. Teams still solved problems, but they did it inside tight boundaries. Parts had to stay cheap, changes had to stay small, and anything that threatened tooling or timing faced immediate resistance. Flexibility mattered less than coordination because the whole project depended on hitting production targets together. So the Pinto program moved forward like a train on a set track. The deadline acted like gravity, pulling every discussion back to schedules and dollars. Engineers could refine what existed, but major rework became harder to justify with each passing week. The cost limit kept options off the table before they were even explored, and by the time prototypes turned into pre-production cars, the real priority stayed clear: build it fast. The first Pinto prototypes moved from drawings to metal, and the next step came fast: crash testing. Engineers sent the cars into controlled rear impacts to see what failed first. The results disturbed them. In some hits, the rear structure crushed in predictable ways, but the fuel system did not stay sealed. Gasoline escaped where it never should have. This was not a small leak. It was the start of a fire risk. A rear-end collision forced the back of the car forward, and parts that seemed safely separated suddenly met under violence. The fuel tank could deform and split. Lines and fittings could tear. In certain tests, the escaping fuel found ignition sources created by the crash itself. That was the nightmare scenario because it happened quickly and left little time to react. The problem was not theoretical anymore. It appeared again under repeatable conditions. Crash testing usually produced a list of tweaks and improvements, but this discovery carried a different weight. A car could be damaged and still protect the people inside. A car that burned changed everything. Engineers recorded what they saw and measured what happened because proof mattered. Each new test forced the same question: did the design keep fuel contained when it mattered most? The answer, too often, came back as no, and the danger followed from that. Engineers did not just point to a problem. They brought solutions. In test reports, they outlined ways to keep a rear hit from turning into a fuel-fed fire. A metal shield could block punctures. The tank could move to a safer spot. Brackets and reinforcements could kept the rear structure from collapsing so easily. None of these ideas sounded exotic. They sounded like normal engineering work. But every fix carried a price in the language management cared about. Extra steel meant extra weight. Extra parts meant extra dollars per car, and any redesign meant time, because a change on paper forced changes in tooling, suppliers, and the production schedule. The proposals did not vanish. They sat in meetings, then in files, then in revised plans that pushed them later and later. So the program stayed on its original track. The danger engineers had measured stayed tied to the existing layout, and the window to correct it narrowed with each passing decision. Small improvements got considered, trimmed, or postponed. Larger changes got labelled unacceptable. In the end, the choice was not between safety and nothing. It was between paying now or accepting the risk and moving forward anyway. The decision had already been made in practice. The Pinto moved from test tracks and engineering notes into full-scale production lines. Parts suppliers shipped in volume, tooling locked into place, and the car took on a new status inside the company. Not a project, but a product. That shift mattered. A known weakness that once lived in controlled crashes now travelled with every unit built. As the first Pintos reached dealerships, the pitch stayed simple, small, affordable, ready for the new compact market. Buyers did what buyers always did. They compared prices, looked at mileage, and drove home believing they had chosen a practical car. But the earlier rear impact results stayed in the design. The risk did not disappear. It had merely changed location, from a lab report to the street. Once thousands of cars rolled out, the math of consequences changed overnight. A rare crash scenario in testing could become an expected event across a nationwide fleet. Every commute, every stoplight, every traffic jam added another chance for the rear of the car to take a hit. The critical point was plain. A hazard the company understood had now been distributed to ordinary drivers at scale. Once the cars spread across the country, the risk stopped being a number on a test sheet. Rear-end collisions happened in ordinary traffic, at stoplights, on highways, in slow-moving congestion. And in some of those crashes, the same weakness showed up again. A hit from behind damaged the fuel system, fuel escaped and fire followed. Survivors described sudden flames and blistering heat. Some never got out. The injuries did not look like typical crash wounds. They looked like burn unit cases, skin grafts, long recoveries, and lives changed in minutes. Families faced funerals after impacts that, on paper, should have been survivable. Police reports and insurance files began to repeat the same elements. A rear strike, a ruptured tank area, then a fast-spreading fire. Each incident sounded isolated. Together, they formed a pattern that refused to fade. As more cases surfaced, the threat shifted in scale. This was no longer a problem engineers argued about inside a company. It became something that followed the car into neighborhoods and onto commutes, turning routine accidents into extreme emergencies. The public did not see the earlier warnings, but they felt the outcome. A compact, meant to be affordable, now carried a fear that spread through headlines, court files and hospital corridors. Impact, ignition and no time. Inside the company, the problem no longer lived only in test reports and engineering memos. It lived in paperwork that measured risk in dollars. The question shifted from how to stop the fuel system from failing to how much the failure might cost if it happened. That change mattered, because once numbers got assigned to injuries and deaths, the decision looked less like a design trade-off and more like a choice. The logic of cost-benefit calculations hardened into a playbook. If a fix added money to every car and payouts looked smaller on paper, the math leaned toward doing nothing. Those documents did not stay neutral. They became a shield, a way to explain delays, to justify earlier calls, and to keep the program moving without reopening the design. The engineering debate started to feel closed, even as crashes continued. Then a new problem appeared, and it was not mechanical. It was legal and reputational. Each internal note, each rejected fix, each calculation created a trail that could be read as knowledge and intent. What once sounded like routine decision-making now carried the risk of looking cold and deliberate. The company needed a defense, not a redesign. And in that moment, protecting the story began to compete with protecting drivers. The pattern no longer stayed inside accident files and insurance claims. Reporters started connecting the same details again and again. Low-speed rear impacts, sudden fires, and injuries far worse than anyone expected from a small crash. Consumer advocates and investigators collected cases, compared notes, and treated them as more than bad luck. When the questions reached beyond individual wrecks, the Pinto stopped looking like a rare failure. It started looking like a systemic one. As the reporting spread, attention shifted from what happened on the road to what happened inside the company. Investigations dug for memos, test results, and decision records that could explain why the danger persisted. The story changed shape. It no longer sounded like a design that went wrong. It sounded like warnings that got managed, delayed, and contained. And once that possibility hit the news, every new crash looked like evidence, not an accident. National coverage pulled in lawmakers, regulators, and a public that had never heard the word Pinto connected to fire. The company faced questions that had simple answers only if nothing had been known in advance. But the reporting kept pointing the other way, toward internal knowledge and calculated choices. The allegation of a cover-up became the headline that stuck. From that point on, the Pinto carried a new identity, a scandal, not a car. Once the scandal reached courts, the Pinto stopped being just a bad headline and became a legal battlefield. Families sued after rear-end crashes ended in fire, and the cases forced painful details into public record. Lawyers dug into testing results, design choices, and what executives knew when. Each filing tightened the focus from tragedy to responsibility. The question shifted. It no longer asked whether the car burned. It asked why it stayed that way. Government scrutiny escalated alongside the lawsuits. Federal safety investigators reviewed crash reports, compared them to test data, and treated fuel system fires as a pattern, not random bad luck. Pressure built for action that paperwork could not delay. Then the turning point landed, recalls and required modifications aimed at reducing the chance of rupture and ignition in rear impacts. This mattered beyond one model. It showed that defects could trigger consequences that reached past corporate walls. After the recalls, the Pinto became a reference point in how America talked about car safety. Companies heard a new warning in every ruling and every investigation. Decisions made to save time or money could return as evidence. Regulators gained momentum to demand stronger standards and faster responses. And inside the industry, safety stopped looking like an optional feature and started looking like a legal duty. The Pinto's damage lasted, but it also changed what came next. Decades later, the rules around crashes did not stay stuck in the Pinto's world. Modern testing standards pushed cars through more defined rear impact evaluations, and manufacturers faced clearer expectations about what a fuel system had to survive. That shift changed priorities inside companies. Safety did not sit on the margins as a nice extra. It became a requirement that could stop a vehicle from moving forward. Fuel system integrity rules tightened in ways that directly targeted the kind of failure the Pinto exposed. Tanks, filler necks, and mounting points had to resist rupture, and designs had to limit leaks even when structures deformed. Regulators watched patterns in real crashes, not just lab results, and automakers adapted with stronger structures and better isolation of sharp components. The old trade-offs still existed, but the boundaries grew harder to ignore. Just as important, the culture around internal warning signs changed. Whistleblower protections and public scrutiny made it riskier to bury a known hazard behind schedules and budgets. Engineers and safety staff carried more formal pathways to escalate concerns, and companies faced steeper legal and reputational consequences when documents suggested indifference. The Pinto era rewarded speed first. The modern era punished it when it came at the cost of lives.